So here are the two problems that had the most wrong answers from yesterday's check-in regarding Euler's method. So we're going to look at those two. So this is this question here, and then this one here with the table. So we're going to start here. Let f of x be the solution to the differential equation dy dx equals 2y minus x with the initial condition f of 1 equals 2. What is the approximation for f of 0 obtained using Euler's methods with two steps of equal length starting at x equals 1? So the little weird part here is that we're going backwards. So when we make our table, we're going from 1 back to 0 instead of what we are used to doing where we're going forward. So here in the table down here, we've got our two steps of equal length written out. So the main thing that we have to deal with the fact that we're going backwards is that instead of adding as we go down, which we've normally done, since we're going backwards, we're going to subtract. So we're going to use the same formula that we normally would, which is yn plus 1 is equal to y to the n plus h times f prime using the old xn and yn. But since we're going backwards, all we're going to do is change those. See, this is an n, this is plus 1, plus 1, plus 1, and going backwards, so we change that to a minus. So this first step is going to be 2 minus h, the step size is 0.5, and then f prime, we're using this differential equation, so 2 times the old y here, minus the old x, and that's going to give us our term for this middle step right here. You plug that into a calculator and you end up with 0.5. Then we plug that in again, minus, because we're going backwards, 2 times 0.5 minus 0.5. And that's how we get the correct answer of 0.25 when I did this, or 1/4. All right, looking at this next problem here with the table, we see that these are values for f prime, again the derivative, and we're starting with x equals 2, and we want to go backwards again to 1.4 using two steps. And this middle one, if you weren't sure, you could find the average of these two to add by adding them together and dividing, and you get 1.7. Nice hint there is that that's what's given in the table. Okay, so once again, really similar. We're going to have to subtract because we're going backwards. So in this case, we have 6 minus the step size, which in this case is 0.3, times the derivative at that point, which we're going to use the table for, and the derivative at 2 is 3, so that'll be our term there, which gives us our new y value approximation, 6 minus 0.9, which is 5.1. And then our last one, we're going to use our new y value, 5.1, minus the step size, times the derivative of this term, which is 1.7, which is 2. And then that's 5.1 minus 0.6, which gives us our correct answer of 4.5. So hopefully with this subtraction, this video makes more sense. The other two questions didn't have as many errors on them, plus from my perspective it looks like there's answers on AP Classroom, but please do let me know if you want to ask any questions on those. Have a wonderful long weekend, or I hope you had a wonderful long weekend if you're checking this later. I'm always here to help.